Hello, welcome back. In this video, we'll discuss the synthesis of nanomaterials with special focus on sol gel technique. The nanomaterials can be synthesized using a number of different ways. However, these methods can be classified broadly into the top-down methods and the bottom-up methods. In the case of top-down methods, the synthesis process starts with a bulk form of the material, and from there we obtain smaller pieces of the material, and then we obtain a powder, and ultimately we obtain the nanoparticles after thoroughly treating the powder. There are two major top-down methods: mechanical grinding and erosion. Similarly, in the case of bottom-up methods, atoms and molecules are taken and they are manipulated one by one to obtain the clusters, and from the clusters we develop the nanoparticles. We have aerosol techniques, chemical precipitation and self-assembly, as well as the sol gel technique. They are the examples for the bottom-up approach. The synthesis methods are further classified into physical methods, chemical methods, and thirdly the biological methods. In the physical methods, we start with bulk form of the material and then we start synthesizing. We also have the vapor deposition techniques falling under this category. The chemical methods are simple and inexpensive. A variety of nanoparticles can be synthesized using the chemical methods. The biological methods, essentially they use microorganisms to synthesize the nanoparticles, nanostructures and nanomaterials. The microorganisms could be bacteria, fungi, yeast, etc. An example for the chemical method is the sol gel method. The synthesis of the nanoparticles depends on various parameters. So we shall discuss the factors affecting synthesis of nanoparticles. The first one is temperature, second one is pressure, third one is time, fourth parameter is particle size and shape, fifth parameter is cost of preparation, the sixth parameter is pore size, the seventh parameter is the pH value, last and eighth parameter is environment. These are the 8 factors that influence the synthesis of nanoparticles. Now we shall discuss the sol gel method. The sol gel method is a bottom-up method. It is a bottom-up synthesizing method. In the bottom-up methods, we start with atoms, molecules. The bottom-up methods involve atom by atom, molecule by molecule, or cluster by cluster manipulation for synthesis of nanostructures. In these methods, the starting material is either in the liquid state or gaseous state. These techniques they include chemical synthesis, self-assembly, and positional assembly. These three are the examples for the bottom-up approach. The sol gel method falls under the chemical synthesis method. In the sol gel method, the sol is a solution with particles suspended in it. A sol essentially is a solution with the particles suspended in it. We shall now see what a gel is. When the particles in the sol form long polymers or chains of molecules that span the entire sol, a gel is formed. In the sol, we have the suspended particles, and when these suspended particles they undergo polymerization or esterification, long polymers of the suspended particles are created in the sol, and these long chains of molecules, when they span the entire sol, we call it as a gel. In the sol gel process, the starting material is processed to form a dispersible oxide. The material is processed to form a dispersible oxide. So we have to convert the material into a dispersible oxide form, and a colloidal suspension of the metal compound is then prepared. That is the starting point of the sol gel process. And after this, the sol converts into a gel after the polycondensation. Now the sol is converted into a gel after the polycondensation. A polycondensation essentially means development of polymers or long chains of the molecules in the sol. When the all suspended particles in the sol, they convert themselves into large chains of molecules, then we call such a substance as a gel. And the calcination of the gel gives rise to the nanoparticles. Calcination of gel gives nanoparticles. What is calcination? Calcination is essentially heating the gel at certain temperature. In certain cases, it will be about 800 degrees Celsius. There are 4 steps involved in the sol gel process. The first one is hydrolysis. The second one is condensation. Third one is growth of particles. Fourth one is agglomeration of particles. The hydrolysis is a process of adding OH minus to the precursor. So when you add water to the precursor, we get the hydroxyl form of the material in the sol. And the condensation process is one in which the polymerization takes place. As a result, one gets the gel. And growth of the particles takes place in the condensation process. So the nanoparticles, they agglomerate into the solid form. That is the bulk form of the material, which is not at all desirable. In this diagram, the sol gel method is explained. We have a solution of precursors. On condensation gives rise to colloidal form of the solution, and this can also be used to produce the powder, that is the nanoparticles, and the sol can be sprayed on a substrate to obtain thin films. So thin films also can be produced using the sol gel method. One can also draw fibers from the sol. When the sol is transformed into gel through the process of gelation, we get the gel, and when the gel is dried, we get zero gel. This drying process is called as thermal drying. When the gel is dried using the supercritical drying method, we get the aerogel. Upon compressing the aerogel, we get the dense ceramic form of the nanoparticles. And when the zero gel, that is obtained by thermal drying method of the gel, when it is ground into a powder, we still get a nanoparticles. There are certain advantages of the sol gel method. Using the sol gel method, one can produce large quantities of the nanomaterials at relatively low cost. Large quantities of nanomaterials can be produced at low cost. Using the sol gel method, one can synthesize almost any material. Thirdly, co-synthesis of 2 or more materials simultaneously is possible. One can produce extremely homogeneous alloys and composites using the sol gel technique. Homogeneous Lastly, high purity materials can also be produced. In this video, we have started our discussion with the 2 different classes of synthesizing methods of nanoparticles, namely the top-down methods and the bottom-up methods. In the top-down methods, we have said mechanical grinding and erosion are the 2 major techniques, and in the bottom-up methods, we have aerosol techniques, chemical precipitation techniques, self-assembly methods, and sol gel methods. We have further seen the classification of the synthesizing methods. They are physical methods, chemical methods, and biological methods. We have seen the factors affecting the synthesis of nanoparticles. A sol gel method is a bottom-up method. In bottom-up methods, atoms, molecules, they are manipulated to fabricate the nanostructures. We use the starting material either in the liquid state or in the gaseous state. Sol gel is a chemical synthesis method. In the sol gel method, there are two different phases of the material. One is the sol, the other one is the gel. A sol is a solvent in which particles are suspended, and a gel is formed when the particles in the sol form a long polymers or chains of molecules that span the entire sol. A gel is formed. So the starting material is processed to form a dispersible oxide, and colloidal suspension of the metal compound is prepared first, which we call as a sol. The sol is converted into a gel after the polycondensation, and calcination of the gel gives rise to the nanoparticles. Calcination means heating the material at high temperatures, maybe around 800 degrees Celsius. There are 4 steps involved in the sol gel process. They are hydrolysis, condensation, growth of particles, agglomeration of particles. We have seen the diagram using which we have explained how the nanoparticles can be produced. We have seen the advantages of sol gel method. Thank you.